Okay, this is SSO 5, 2013 question 3. We're going to use it to demonstrate use of graphical calculator where appropriate, answering questions where you need to use a hypothesis test for the difference between two variances, and a hypothesis test that's using the F test, and for the difference between two means where the sample's small, which requires the T distribution. Without reading through it too much, you're testing for a difference in yield in grams between tomato plants that have got two different types of fertiliser. Now, you have got two small samples, and you are required to summarise those samples to find the mean and standard deviation. Josh is just going to demonstrate how you can use the graphical calculator to find the mean and standard deviation.
This is how to work it out for Morton, the top one. You go to menu 2, and in list 1 you would type in all the values for Morton. List 1, sorry. And then you go on calc, 1 var, and the top, the x bar, is 1377 as shown there. And you would look at SX, because you want the sample standard deviation, and that is 18.4.
You would then delete those values and put in Tom's plus in order to repeat the process to get the mean yield in grams for those plants that have had Tom's plus fertiliser and equally the sample standard deviation. On to the question, part A. Show, using the 5% significance level, there is no difference in variability between the yields from plants using Morton and yields from plants using Tom's plus. Hypothesis, that the standard deviations are equal. For the null hypothesis, that there's a difference, that they are not equal for the alternative. That is a two-tailed test at 5%, so your critical value, you need to be aware that the critical region is split 2.5% either side. Now, to work out your test statistic, from your notes you know that you use the variance, the larger variance on the top, 18.4 squared, and the smaller of the two variances on the bottom, 17.8 squared, and you do that division on your calculator and you get the test statistic 1.07. Now, to find the critical value, you use the number of values, or for the sample that was used on the top, which happens to be the Morton, was 10. 10 take 1 is 9, so you're looking up F9, 8 take 1 is 7, so F9, 7. In your tables booklet, for 0.975, because it was a 2.5%, 9 degrees of freedom, 9, 7, gives you the test stat 4.823, critical value 4.823, or alternatively you can use that, you can find it from your graphical calculator that Josh is going to show you.
So you would do option, stat, dist, and F. You then do in F, and because it's two-tail, it's 0.02597. Execute, and that will get you 4.823.
Whichever way that you do it, please, I would advise showing the critical value on the quick sketch. There's your critical value. Obviously your test stat is not in the critical region because your test stat is here, 1.07. Hence you accept H0, that at the 5% level there is no evidence of a difference in variability. That's actually quite useful because we can now, we know where we're going with part B. We can assume that both populations for the yield more Tom and the yield given Tom's plus fertiliser can be considered to have a common variance. Part B. Investigate at the 1% significance level the claim that the mean yield from plants grown using more Tom is greater than the mean yield from plants grown using Tom's plus. So you're testing for a difference in the two means. This is a one-tailed test, hence the alternative hypothesis. Your test statistic, I advise you to look at page 12 of your tables. It's going to be a t-test, we've already mentioned that, small sample. That is going to be, we know that you can use a common variance. We need to work out the pooled variance, and we're going to use this as your test statistic. Don't panic about the pooled variance, it looks horrible but it isn't really. So I'm going to work out the pooled variance as we need it. First, 7 multiplied by 17.8 squared. Here we've got sample size 10, so that becomes 10 to the 1 is 9 multiplied by 18.4 squared. The value on the bottom, sample size for more Tom plus the sample size for Tom's plus, take 2. 10 take 8, take 2. On the bottom, calculation gives you a value of 329. That is now going to be used as the pooled variance in this formula here. So the test stat, you can check those values I got from over here. Putting those in, that gives you a test statistic of 4.101. We are now going to compare that with the critical value from the t distribution. Now you should be aware that the number of degrees of freedom is 16 because it is the two sample sizes, 10 plus 8 take 2. Essentially it's 10 take 1 plus 8 take 1. So that is 9 plus 7 gives you 16. You can use your tables booklet in the usual way. T distribution with 16 degrees of freedom, 1% right hand tail, 1% right hand tail, 2.583. Josh is now going to show you how you can get that using your graphical calculator.
So again, you would do option, stat, dist, t, and in for t. Then you would type in 0.01 and 16. And that will give you a value of 2.583.
To finish, you do the comparison. Where is your test statistic? Test stat 4.101 is clearly well within the critical region over here. So you conclude, you reject H0, that there is significant evidence of an increase in yield using Morton fertiliser at the 1% level.